Dear students, now we are going to discuss about the problems in classes inequality. So before we move to the problem, first we know about the Clausius theorem. What we finally found in the Clausius theorem, that is cyclic integral of that is dq by d which is equal to 0. Here what is cyclic integral of dq by d? Dq already you know which is called as a change in heat transfer. T is the temperature. How we can represent cyclic integral of d? So listen, if you consider this cycle, this is the entire cycle. In cycle, it is this is the entire cycle. In a cycle, we divide the cycle into number of adiabatic process. These two are the reversible adiabatic terms. Then these are the reversible adiabatic lines. The number of adiabatic lines. Here in adiabatic time, in some lines that is called reversible isotherm lines. The cycle is divided into some divisions. So finally, we are getting this is isotherm line and they're having adiabatic line. Here, this is the PV curve. Simply, we can given in terms of say it is called as the PV curve. So, what dq by integral of dq by t? Note that here um, the cycle here this is isotherm. There is a temperature remains constant. It's a reversible adiabatic line. There is a here the heat transfer that is equal to 0. Change in heat transfer. Here also the change in heat transfer that is equal to 0 because this is a reversible adiabatic. Red color lines are reversible. Here the green color lines are reversible isothermal line. Here the reversible isothermal line it is the constant temperature. Here is the constant temperature. dq that is a heat is added at the this reversible isothermal line. Some heat is added. Here the heat is rejected in this reverse isothermal lines. So finally, the heat added at corresponding temperature, the temperature we can constant, which is here represented as a T1. Here the this temperature represents T2. The heat rejected, that is the dQ2 at temperature T2. So dQ1 with respect to temperature. Here adding the temperature, that is dQ2 with respect to temperature T2. This is for one cycle. The next you are considered this cycle. Okay, this cycle we are having that is a dq3 heat is added at temperature T3. Here dq4 heat that is rejected at temperature T4. There is a dq3 divided by temperature T3, then dq4 divided by temperature T4. By adding all the dq's in a cycle, dq by t in a cycle, we are getting 0. Why? Because 0? Because it's a reversible process or reversible isothermal process. So here what are the heat that added in the dq1 at the temperature T1, the same amount of heat that is rejected at a temperature T2. So for that process, it is a reversible 0. So that's why you are getting cycle dqdt for a reversible cycle is equal to 0. This is the Clausius theorem. From the Clausius theorem, we derive some relation that is called as a Clausius inequality. So in a Clausius inequality, we have a three cases. That is called as a case 1. This is a case 2, not a case 2. These are three conditions particularly right, that is not a case, that is a condition 1, condition 2, that is a condition 3. What condition 1 says, the cyclic integral of dq by t is equal to, already we studied, we have two isotherms in having two adiabatics. So it is the heat added, that is a dq1 at temperature T1, the heat is rejected, that is dq2 at temperature T2. So we consider these three. This is a reversible adiabatic lines. So reversible adiabatic line, the heat transfer is 0. In isothermal line, the temperature is a constant, but heat transfer exists. Okay. So here the dq1 for condition 1, there is a dq1 at a temperature T1 plus dq2 at temperature T2, which is equal to 0. So for this case, the cycle is called as a reversible. Second case, there is a dq1 at a T1 plus dq2 at the temperature T2, that is a less than 0. Less than 0 means you are getting negative value. This cycle is called as irreversible or possible cycle. Okay, that is a less than 0, that is a irreversible or possible cycle. Here there is a entropy occurs. Entropy is available in the case of reversible cycle and possible cycle. dq by d is negative. Similarly, at the same sign opposite, we are having entropy value that is a positive. The next case, The third case, there is a dq1 divided by t1, same dq by divided by t2, which is greater than 0. So if it is greater than 0 means the cycle is impossible and it violates the second law. Because there is a no loss, so always we are having a efficiency more than 100%. So it is that violates the Killing-Planck statement of second law. So by using this case, we solve the problems in a Clausius inequality. Okay, listen here. The first case, 300 kilojoule of heat is supplied at the constant fixed temperature 290 degrees Celsius to a heat engine. Okay, to a heat engine. The heat rejection takes place at 8.5 degrees Celsius. So this 300 is equal to, there is a heat added, call it as, that is called as a Q1. This 290 degrees Celsius, that is called as a reservoir temperature, and that is called as a T1. The heat rejection takes place at 8.5 degrees Celsius, that is reservoir. It is otherwise is called as, that is a source. This is called as a sink. It is also reservoir. Already we studied, we know in the thermodynamics, Kelvin's this is takes place. The following results are obtained. So the first case, 215 kilojoule of heat are rejected, 150 kilojoule of per second heat rejected, and third one is 100 kilojoule. So for this, we convenient, we draw the term, so which is equal to, similar to the heat engine in a Kelvin-Planck statement. So T1 is equal to 290 degrees Celsius. So which equal to 290 plus 5, we can consider that is a 290 plus 273. We are getting, that is called as a 563 Kelvin. T1 is equal to 563 Kelvin. Similarly, we are having a source. T2 is equal to 8.5 degrees Celsius. So 8.5 plus what? That is called as a 273. We are getting, so T2 is equal to 281.5 Kelvin. So this is the source one. This one is called as a sink. So in between that, we are having a engines, the heat engine. So that is, we call this, that is called as a reverse engine A. Then we are having a one engine, but the heat is, you consider one condition 1, condition 2, condition 3. Here there is an engine, all are same engine, but the heat rejection takes place. So you consider this also take a, this also take a for our convenience. So first case, in all the three cases, Q1 is equal to 300 kilojoule per second. Here also Q1 is equal to 300 kilojoule per second. Here also Q1 is equal to 300 kilojoule per second. But in the condition, there is in the first case, the heat rejection Q2 is equal to 215 kilojoule per second. In that case, Q2, in the second case, Q2 is equal to 150 kilojoule per second. In the third case, Q3 is equal to 75 kilojoule per second. Okay, all the engines are capable of doing some work. The engine is same, but the heat rejection is different. So here the source temperature, please listen that your source temperature are same, sink temperature are same, heat addition for all the cases are same. The only difference is heat rejection. So now we find which one of these three is a possible or irreversible or impossible, or all the three are irreversible. We are going to find that. So first one, we are going to find condition 1. Already you know that is cyclic integral of dq by t, which is equal to q1 by t1. Heat rejection we are simply written as minus, so q2 by t2. Here q1, what is a q1? 300. 300 divided by what? 563 minus, here the q2 is equal to what? 215. 215 divided by, that is a 281.5. Finally, we are getting a value which is equal to minus 0.02309. So this value is less than 0. What? This value is less than 0. So from that, you know that is cyclic integral of, for this case, cyclic integral of dq by t less than 0. So if it is less than 0, what is the name of the cycle? If it is less than 0, the cycle is irreversible and possible. So we call this one is called as a irreversible or possible. Okay, now we move to the second case. Second case, again, there is a cyclic integral of dq by t, which is equal to q1 by t1 minus q2 by t2. Again, for this case, q1 is similar for all the cases because 300 divided by 563. Q2 differ. Q2 here it is 150. 150 divided by 281.5. It's not working. Finally, we are getting the value which is equal to 0. So here cyclic integral of dq by d is equal to 0. So second case, it is called as a reversible process. Okay. This one is what? Irreversible. This one is reversible. Then third one. Third one, again, cyclic integral of dq by t, which is equal to q1 by t1 minus q2 divided by what? T2. So again q1 is equal to 300. Here t1 is equal to 563 minus here q2 is equal to 75 divided by 281.5. Not okay. 281.5. So here you can write down that is 75 divided by 281.5. You neglect that. So we are getting the value which is equal to 0.263 something, so which is equal to greater than 0. So here the cyclic of dq by d which is equal to greater than 0. This is the third case. So from that your third case cyclic of t is greater than 0, then this is called as the impossible cycle. So this third one is the impossible cycle. Okay, so here the source is same, sink is same, heat addition is same, only heat rejection is different. From the heat rejection, we find which is the possible cycle or impossible cycle and reversible cycle. Similarly, we have another one problem. This one problem is similar to that one. Here it is a 400 kilojoule per cycle at a temperature of 327 and heat rejection at sink is 25 degrees Celsius. Here we solve the problem similar to the previous one. So having temperature T1 is equal to 327 degrees Celsius plus 327 to 73 we are getting, which is equal to 0, 0 and then 600. So T1 is equal to 600 Kelvin. We are having a what? Sink temperature T2. So T2 is equal to 25 degrees Celsius. So 25 to 73 we are getting T2 equal to 298 Kelvin. T1 is equal to 600 Kelvin. So it is connected by the same engine EA. Here it is given as A, B, C. So for that we are taken EA. Then we are having a EB. Then EC. So 400 kilojoule per cycle of heat is added 327. Here Q1 is equal to 420. Here Q1 is equal to 420. For this Q1 is equal to 420. This is called as source. The source which is at 327 degrees Celsius. This one is called as what? Sink. So sink is at 25 degrees Celsius. So all are capable of doing work. Then hypothetical amounts of heat rejected in A, B, C below. Compute the cyclic integral of delta Q by T from the results on which case is irreversible, which is reversible, which one is impossible. So here the heat rejection can be added. So first one 220 kilojoule per 220 kilojoule, that is a Q2. 220 Q2 is equal to 220 kilojoule per cycle. Here second case Q2 is equal to 105. Third case Q2 is equal to 315. So finally we solve which is irreversible and reversible or possible. So first we are discussing about A. A, that is already you know, that is a dq by t, which is equal to q1 by t minus of q2 by t, because q2 is a heat rejection, this is a heat addition. Q1 is heat addition, q2 is a heat rejection. So finally we get a value that is 420 divided by 600 minus of 210. 210 divided by 298. So we are getting the value which is equal to 0. So here the cyclic integral of dq by t is equal to 0. Value is equal to 0. The first case, this case it is called as what? That is a reversible. So this one is reversible case. Then second one, that is second case, cyclic integral of dq by t, which is equal to q1 by t, again t1 minus q2 divided by t1. Here q1 is a 420, q2 is equal to 105. Here it is a 420, there is a 105 minus, sorry, 105, not a it's a 105, it's a temperature 600, sorry, 600. Q2 is equal to 105 divided by the temperature is 298. We are getting a value is equal to 0.35. So which is greater than 0. So here cyclic integral of dq by t greater than 0. This is second case. This one is the first case. So here call the cycle that is called as an impossible cycle. So second one, that is impossible. It is impossible. 105 kilojoule, that is called as a impossible. Then we move on to the third one. In the third one, see again dq by t, already you have formula q1 by t minus q2 by t, which is equal to 420 divided by 600 Kelvin minus here third one, that is a q2 is equal to 315. So 315 divided by temperature is equal to 298 Kelvin. We are getting a value of minus 0.35. Here the cyclic integral of dq by t, that is equal to less than 0. So the third cycle, this one is called as a irreversible cycle. Okay. So finally, from the three things we are noted, so if heat rejection is higher, we call the cycle that is called as a irreversible cycle. It is called as, otherwise that is called as a possible cycle. If heat rejection is too low, so here 210, 105, 315. So this cycle is irreversible, that is called as a possible cycle. That is a real cycle. Heat rejection is somewhat 210 at the temperature, that is called as irreversible, because we are getting 0, there is a no losses. But if it is heat rejection is too much low, that is 105 compared to these two, this cycle is called impossible cycle. So from that you know that some heat rejection is really occur in the real, possible or irreversible cycle. Okay, so these are the problem in a Clausius inequality, whether the cycle is possible, impossible or reversible. Okay, thank you.